I can present.
Okay.
Hello. Tell me when you're ready. What's that? Oh, you do? Okay. So we're good? Hello. Good morning, everybody. My name is Benjamin Abramson. I'm with ABR Industries. I'm going to talk to you today about kind of a perspective and a synopsis of what is actually utilized in the amateur radio market, give you some understanding about what the differences are, give a little bit about what the math is, but I'm going to kind of gloss over a lot of the math. If you do have specific questions about that, we can talk after, or I can reference you back to Chuck, who's our technical expert back in Houston. I also want to encourage, if there's any questions, don't be shy here. Nobody's shy, so ask away, okay? Just kind of an introduction to ABR Industries. We are based out of Houston, Texas. Actually, most of us did grow up in northern Illinois, so we are very familiar with this area that we're in today. Used to come up here all the time. We are a supplier of U.S.-based cables. So there's a lot of difference that you see out in the market. There's a lot of cables that you get from different countries that have different requirements. We follow the U.S. requirements. We also build our cables to our specification in U.S. factories for more of a control factor than anything. It is a little bit more expensive at times. Won't dispute that, but a couple dollars can go a long way when you want to get something that you've paid all this money for. So I'll give you a little understanding about the differences and what we bring to the table. We do build our connectors overseas, but we do actually have control over the process. We do all the engineering behind it before we go and submit it to the factories, and then they go and build it. They have the equipment. We just don't have it here in the United States the same way we can build it overseas. But connectors are the only thing the cable is built here because you don't have as much control over the cable overseas that you do the connectors. We use precision tooling. We spend a lot of money on our tooling, and the reason we do that is because it's precision. Precision is probably one of the most important things, and I'll get into it as we talk about things like the center conductor and the different aspects of the cables and the connectors and the difference between all of them. So it gives you a perspective. And why we utilize this tooling is because it makes a precision cut every time. Same thing every time. You want to get a product the same way you want the same product. We don't want to make it different from one to the next. We want to make sure that you're getting a precision product that you're going to be able to put up and you're never going to have an issue with. We are trained on ISO 9001, although we are not ISO 9001 approved. And the reason being is it's just a process that we don't feel that is necessary for us to go through. But we did go and look at our process and how we build everything and how we do everything. And we've really refined it so that it follows that precision process. Which is why, as you look at, we do test every assembly. As well, we do provide the highest quality product. And the reason we do that is because we follow that precision process. And it's paid off over and over because we give you a high-end quality product and you don't have any issues with it, which is what we want to do. When you buy something, we want to make sure you're happy. So I'm going to kind of go through just an overview of coax cable, go into a little bit of the math. I'm going to connect the dots a little bit for you. I'm not going to go into the details. Talk about some of the popular cable products, give you a little perspective about what they do and how they stand out differently from others. And then we're going to talk about the connectors as well. And like I said, if there's any questions that anybody has, don't be shy, just ask away, okay? So what is coax? Coax, from a macro perspective, was built in the late 1800s, early 20th century is really when they started to regulate it and be able to connect the dots so that what you were getting in one place, you were getting in another place as well. And it's really a matter of consistency is why we look at it and how the coax cable industry has really grown over the last 100 years. But 100 years, as everybody knows, is really an infancy in the overall scheme of things when it comes to any kind of technology. So why is it important? Because coax cable is a little different than some of the other things. You know, most of you probably know more about electrical cable. Coax cable is something that has started to come around really only in the last probably 70 years since World War II is when people started utilizing it because we were using satellites. We were connecting and trying to figure out and trying to connect to each other through communication. So that's why coax is different than a lot of other cables, but at the same time, it's a very important cable that you're starting to pop up and see a lot more today than you saw, let's say, in the 90s. So I'm going to talk a little bit about the math. So the impedance. So let's look at like a fighter jet. going through the air. If you have impedance, impedance is really the relative difference from the center conductor to the overall size of it, which all of you guys know. I'm not teaching you anything you don't know, but where it connects to the fighter jet is that what it's trying to do is go through as fast as possible, which we'll see in the next step, but try to stay within the air. And so its physical terms is really very similar to what you see with cable. So that center conductor is just like the plane going through the air. So give you some perspective on that. But the signal is, what do you have there? What are you utilizing? What is the jet made of? How is it going through the air? And then we'll talk about the next piece as to where your losses come in. So what are you fighting against in that fighter jet? It's that attenuation. It's that dB loss. You're getting your gain out of your antenna, but you're getting your loss out of your cable. And when we talk to you and we give you suggestions on really two things. In a retail market is what do you need versus what do you want? We'll tell you every time what you want in relative cable, but a lot of times, like if you're using HF, and we'll get a little bit further into this, a 218X is perfect. It's what you need. The loss characteristics in relation to your antenna work out perfectly, and you're not going to get really any loss in that regard. But if you're moving up to 2 meter 440, that's when you move up to a little bit larger size, a 400 size, which is a slightly larger cable, a little less fluid and moving around, but a cable that you pretty much need relative to those requirements. So it's just a matter of we're going to talk to you about what do you need versus what do you want. Because there's a lot of great cables out there, but you don't necessarily need them all the time. I can go back on the math if you want, but if you really want the details on the math, I'm a statistics guy. I know the math in that regard. Chuck is my older brother. He's a physics guy. He can talk to you about all the physics if you're kind of running into numbers. You're just a little unsure as to what you want to do and how you want to break it down because you really want to run the numbers. He can talk through and run the math for you. It's not a problem. Don't ever hesitate to reach out to us, okay? Center conductor. Center conductor, as we talked about, is an unbelievably important aspect to it. And there's really that stranded versus solid center conductor. So you're going to get, obviously, higher losses if you have a stranded center conductor because it's not going to move as smooth through the air, just like a fighter jet, right? Where the stranded is going to be frayed at times. And that's why when you're putting a connector on, that stranded center conductor, although great and maneuverable, can be quite tough to get that PL59 or any of those end connector or whatever connector you might be using because it does have a tendency of fray if it's not stripped the correct way, which is why the precision machinery comes into place. But the center conductor is a very, very important thing, and you do have, as it states here, about 10 to 15% loss on a solid center versus stranded being higher. And so you'd see the difference, like from an 8X size, you have a 240 solid, a 400 flex, you have a 400 solid. You're going to have lower losses, but if you're using a rotor, you want that stranded center conductor, so you want to be able to account for the slightly higher loss that's associated with it. If you're running long distances, I'm going to always suggest to you to go with the solid center conductor because it's going to give you lower loss, and it's going to connect to the center to the macro size of the cable, as we were talking about in the impedance side of it, and how it's so important to that, because it does have an effect on the connection that you're getting when you're on your radio. Dielectric. This is another one. There's 3 different types, and so I'll give you some examples. Solid polyethylene used to be a 9913 that was built years ago, and it was used with the solid polyethylene. Where the 9913, it's obviously an older cable, but where there was issues that it was running into is, with most cables, you always have issues that if you get water into it, if you don't connectorize correctly, you can get water into it. Where the solid polyethylene had before, so you don't see it on 213, it's just a solid polyethylene, there's nothing coming in there. What 9913 had was an air core dielectric that was in there within the solid polyethylene, which allowed for water to get in there and obviously shorting your cable. So that is why that cable was great back in the day, but what they came to realize was that it had, because of the air core dielectric, it was opening up for water that was getting into there. So just perspective on what a solid polyethylene does. Solid polyethylenes are not utilized as often in this market today as they used to be, but they are great for high power. So like, for example, 213, if you're using a linear amplifier, a solid polyethylene is a fantastic product. And that's utilized on the 213. But it's not on the 400. It's not on the other products that's some of the products that we sell. Now you have then gas-injected foam. So that's a great product as well. That's going to also, obviously you have gas. It's going to be very sturdy to hold up, but it's going to be a little bit more maneuverable than a solid polyethylene, which is why sometimes, depending on the size of it, you can't run as much power through it as you would a solid polyethylene. Because if you've ever stripped the gas-injected foam versus the solid polyethylene, you'd know there's a distinct difference there. One's very hard, very stiff to get through, and then one's very soft, very easy to get through. Not necessarily saying it's any better from the standpoint of loss characteristics, because it's not. It's the issue that you run into with power. Power can be, you can get more power through a solid polyethylene. Now, if you want a lot of power that you want to run through, the PTFE is fantastic. So that's, in essence, considered a Teflon, probably heard of. But PTFE is the word. You can run a lot of power through there, because Teflon on the outside, then typically, with most of those Teflon cables, has a silver center conductor. And so then it's silver braid as well. So it allows you to run a lot more power through there. Expensive, wouldn't suggest it for a lot of things. It's not, even though you have like an RG400, it's stranded center conductor, but it's not as flexible as like a 58 with a stranded center or a 218X with a stranded center conductor. It's just going to be more stiff because of the Teflon PTFE coverage on it. Does that make sense? But what I can tell you is all of our cables, including the PTFE, is crush resistant. They do use them out in the field. They run over them with the cars and trucks and everything, and so they do hold up pretty well. Shielding is another thing. Shielding is extremely important. So a lot of cables that you've seen out in the market that typically are a little bit less expensive, it's a shielding issue. Always ask, what's the percentage of shielding? Now, our cables, sans the 213, which is considered a mil spec, which is 96% braid coverage, are going to be double shielded. They have not only the foil, but they also have the braid as well. So it gives it what's considered 100% braid coverage because of the tin foil. And it's going to be your best bet for everything. A double shield, like a double silver shield that you might get in a Teflon type product or a PTFE product, that's obviously going to hold up a little bit better. And you're not going to get as much interference as there as well. So if you have less braid, you can plan on more interference. And obviously, we don't want to deal with that when we're in our hobby, right? Jacketing. So there's really 3 core jackets. You have type 1, which is just going to be a basic UV resistant. It'll hold up. That's what most cables are made of. Now, we on our cables actually do use a type 2. It's direct buriable, but when we say direct buriable, yeah, you can bury it, but it's going to hold up in the weather elements considerably better longer term than the type 1 is going to be. It's going to last about 20 years for that jacket. And it does hold up, because I can tell you, we've had some of that stuff out there for about 20 years, and it's held up perfectly. And then you have a type 3, which it's a higher chemical resistance. It's like armored options. What we do is, so for example, we sell lots of the energy industry being in Houston. And so what we've done is we've, in essence, put steel braid over like a 400 solid or a 240 solid that's gone out and being utilized out there, because it's being run over by semis. It's being run over by just about everything, because it's got to cross roads. And so it is a type 3 jacket. We do offer that, and that's something that's out there, but it is very far and few between utilized. But typically everything, and what we do on all of our cables, is the type 2A, because it's going to stand out against the weather for 20 plus years. So why do we do all this? It's based off of, like I said, back in the early 20th century, the government came up with the RG system. And it's a great system. I mean, you've probably seen it in a lot of different things. What 400 is a variation of an RG8U. What 240 is a variation, same size, of a, what would the size be on that one? It would be the 8X. It's not a specific number on the 8X, but on the 400 and the 9913 that we were talking before, that would be considered a 400 size cable, or an 8U, RG8U type cable. So when people say, hey, I have an RG8U, there's 100 different variations of RG8U, different types of size cables, because you could have something with a foam dielectric, you could have something with a solid polyethylene, you could have an air core. There's a number of different types of cables that even have just that RG. So when somebody says that, an RG8X, an RG8U. It's just relative to the size of the cable. Okay? So cable that are popular with amateur radio. This is probably what you guys really wanted to hear. I didn't want to hear all that stuff, so me talking for the first. This is going to give you some insertion loss. This is like looking at HF, 2 meter, 440. This is typically, for the amateur radio market, what you're going to look at. As you can tell, the 600 is going to be better. It's a solid center conductor, so it's going to be lower loss. It's the largest cable of this group. So across the board, you're going to have your velocity of propagation numbers going to be looking very clean in that regard, too. So great products, but the 400, if it has a UF on it, that means it's a stranded. If stranded, it's going to be specific to cables that can be used rotor, or you want something that's going to be able to be flimsy that you can use and work with within a car, within just about any angle, and you're using HF, that 240 Ultraflex or 218X that you guys see it is in line with what you would typically want to use. And I'll show that. So 600, I won't go through much of it. It's a Type 2A jacket. It's 50 ohm, and all the cables we're going to probably talk about today are going to be 50 ohm, because that's predominantly what's utilized. And 50 ohm is focused on communications. If we got to 75 ohm, we'd be at video. But most of it's all going to be 50 ohm. And this is best for VHF and above. We won't typically suggest this because this is typically a want, and that if you're willing to pay the money, it's a great product. I will not dispute that in any way, but it's not necessary. It's a very big, very stiff product. I mean, we do carry the 600 Ultraflex as well, but it's still pretty stiff, even with the stranded center conductor in there. What we typically suggest, even up to 900 megahertz, is the 400. Both the 400 solid if you're doing long runs and you want that solid center conductor with the lower loss, or the 400 Ultraflex. And as you can tell, I mean, look at the nominal differences of what you're going to see on the loss characteristics and the power. At like 30 megahertz, it's 0.7 and 3.3, where it's 0.8. Not a big difference on the dB loss, but the power you can get through there is pretty much a big difference. And that's just a solid versus a stranded center conductor. So if that gives you any kind of perspective, it's very similar to how you see in 240. Or this is going to be 213. And like I've said before, the 213 is a great solid polyethylene product if you're running a linear amplifier. This is the kind of product, if you're doing HF, you're doing 2 meter. Typically, if you're going up to 440, we're going to suggest the 400 Ultraflex. But if you're doing HF and you're running a lot of power, this 213 is perfect for you. If you're running 2 meter, the 213 is what we're going to typically suggest. It's a very great product. It's just going to be a little stiffer than what you're going to get in the 400 Flex, because it's got the solid polyethylene versus the other. This is the 240. So the 240 solid, as we were talking about before, everything is double shielded, as you're seeing, outside of the 213. What you're going to see as well, 30 megahertz, 1.3 and 149, you can run a fair amount of power through there. You can, it's got a fairly low loss from an HF standpoint, which is why we suggest the 240 and the 240 Ultraflex. It's a little bit higher on the Ultraflex, a little bit lower power you can run through there, but it's still an awful lot of power that you can run through on HF on the 240 Ultraflex. It's as well, there's a very low loss, relatively speaking, for what you're running on HF, especially with the gain that you're getting on your antenna. Then we do 316. 316 is at 174 size, at RG 174 size that you see. It's typically for your HT. We sell it through HRO and on a lot of different variations. Typically, if you have a Bayo Fang, you're going to use the female SF. And if you have the other products that, like ICOM or Yaesu, you're going to use typically that SM male. So that's typically what you run into the difference. Or if you have an HT that has slightly different connector on the top, you can always look and talk to anyone at the store or with us. But there's a lot of different variations on this. But 316 is a great product. It's a Teflon base, but it's only a single shield, where most of the other Teflon PTF based are going to be double shielded, double silver shielded. This is just a single silver shield, but it is a silver shield. So when you're dealing with this versus like a 100 size or a 174, you're going to be able to run a little bit more power, and it's going to be a cleaner connection on the 316. So when you're looking at it, do know there is a difference on your HT when you're dealing with 316 versus some of these other cables. So what are the typical connectors? So the connector is UHF, like a PL59 is the male version, the SO is the female version. Now, PL59s have been around since World War II. Let's look at it, start off almost like a hose. So a PL59 is allowing you to run as much water through there as possible, but it's not going to be as precise as, let's say, an N-type. An N-type is, okay, now you've put the sprayer on the hose, and now you're getting much more precise connection. And that's why N connectors, we always suggest N connectors versus a PL. Now, most of the radios that you see, most of the antennas do have PLs today, but I know that they are migrating towards an N connector, and the reason they're doing it is for more precision. So a lot of the amateur radio market has asked for that, and that's what they're working on getting. And so it is correct. You have these high-end cables, but you're using a PL59 which is not as precise as an N connector. So like a 400 flex, the correlation would be the N connector versus the PL59. It's a very high-end product, and it's not to say that it's going to necessarily affect your loss a lot, but it will allow for the connection to be that much more precise. And it does have an effect at the end of the day. You can definitely tell when you use a PL59 versus an N connector. So just something to think about when you're looking for radios, when you're looking for antennas, when you're looking for connection and you want that precise connection. The N connectors are a much more precise connector, and which is the common offshoot to the PL59. The BNC is another product, very precise as well. This is a great product, but it's just not utilized as often. But BNCs are great. They're used a lot in the 75 ohm world. So a lot of the 400 flex that we sell into a lot of the broadcasting goes with BNCs on it because it is a precise connector, a lot more than what you would typically get in some others. And then the last one that's used, and you're starting to see pop up a lot more places, is the SMA. The SMA for years was not something that was utilized as much as it is today, but the SMA is a great little connector, very precise, very helpful when you're needing it for your applications. But difficult to utilize on a 400. There is use of SMAs on 400, but it becomes a little bit more wobbly, so you have more of a physical effect of an SM on a 400 versus an SM on a 195 or a 240 size cable. Make sense? So solder is a big one. This is a lot of questions that end up popping up. Solder versus clamp versus crimp. So you have soldering. The soldering with the standard shield and the 4 weep holes, it's limited space. And so what you have when you just solder, you have that wiggle that you're going to get in there, very similar to what you get on a clamp. So you're just wiggling more at the bottom versus the top. But what we do is we not only crimp it so that you get the back end ferrule to make sure that it's all connected so that you get the right connection, but then we also solder the center pin so that we lock it in from the top and from the bottom. And one of the things about crimping, and one of the things as well that is very important, is crimping when you're doing it by hand. You're doing it on an oval shape. All of that has a direct effect on what your connection is and what potential moisture you're going to get in that cable. So when you crimp it with a 360 crimp and the right type of pressure, you not only not get water in there, but you're also going to get a better connection, especially when you're doing this. So when you're trying to strip this cable, so like let's say, for example, a 400, it's got that tinfoil on the bottom. So you're stripping. You strip it down, you got the braid covered, but then you're getting the tinfoil. And you have to make sure that you got all the tinfoil off, because if you have any tinfoil on there, you can affect the attenuation. So that does have an effect. So if you don't get it right, so you want to make sure that you strip that cable right, but then as well, you want to make sure that you're putting the connector on correctly. PLs are a very difficult connector to actually put on. I think people underestimate it. I've done connectorization for 30 years now. A little bit older, can't see as well, so I don't really do it that much anymore. But I will tell you with no uncertain terms, it's not an easy connector to put on because it's not just a matter of soldering it, it's a matter of stripping it as well. And if you don't strip it right, you can have a connection issue and you get moisture in there, and a cable that could last you 10 to 20 years is lasting you 10 to 20 days if you put it on incorrectly. So it is something to take in consideration. That's why we do push people and why we've moved to connectorization. And that's where our strength is. We have all the machinery that does all the connectorization. We have the team that actually are experts on this, that do this on a day-to-day basis. We probably sell and shoot out about 3,500 pieces a week. And so we do a lot of other type of connectorizations above and beyond the amateur radio market. So these are things that we wanted to make sure we connected the dots for you as amateur radio operators. But if there's other things that you guys are looking for from a commercial standpoint, we also want to make sure that you guys understand that as well, that we do a lot of different things. So when we talk to you about this, we talk to you from more of a commercial standpoint in that we know you're an amateur radio operator, but we want to make sure you understand what you need versus what you want. From a commercial standpoint, they're always looking for what they need. From an individual standpoint, when you're coming out in retail, you want to go buy what you want. And so we make sure that you understand both ends of the spectrum and that you have a full picture of what you're doing. So if you're ever looking for and wanting to understand the math and you're trying to break that down, Chuck, our technical expert, can help you with that. If you're trying to understand, you have a configuration and a setup and here's what you're looking, we can help you with that as well. We're here to make sure that we can answer your questions. We don't have any biases towards any other companies. We just want to talk to you about what we can offer and what we do and why we give you a product that you're going to be able to utilize for years to come and never have a problem with. And that's our focus, is to make sure that we're being precise and doing and getting you what you need. We build it to your specifications. That's what HRO provides for you guys. They provide a number of different products that we build. They now offer with ferrites on it. There's a lot of people that have said that they've had a lot of interference. You know, you have a lot of cell towers, you have a lot of power lines that create interference on a regular basis. So now HRO is carrying the ferrites on it, already preset, and it really does help. It really does have an effect. We do a lot of testing, did formerly at our father's house, Chuck's house, not mine as much, can't get into my backyard, but unfortunately, but we do utilize and set up a lot of different things, and we talk to a lot of different people with a number of different setups and see what their successes are and where they may have not had some, or may have run into some issues relative to their setup. So we can correspond, we can talk to you about that if you do ever have any questions. Other than that, that's really my presentation today. Any questions?
I got one question.
Yes.
Sorry. So the foil versus braid shielding.
Yes.
There is a lot of discussion in the land mobile two-way area about using those cables and getting in duplex situations where you get noise because of the similar metals. You guys offer a cable that's completely, other than the smaller stuff that's completely braid shielded, that's double shielded in the RG8 size.
Yeah, so like a 213 would be a prime example of that. The 213 does not have the shield. It's a mil spec, military specification, and it's 96% braid coverage. And so it is a copper braid. And that is another thing with braid coverage. You talk about braid. There's a lot of stuff that you get that when you don't have control over the process and is built at a subpar, the braid can fray. So if you see and you're ever trying to connectorize everything and you're stripping something, the braid can fray because it's not made by copper or tinned copper. It is a variation of that, and it will fall apart. And when you do and have that, you do get a lot of interference. Some of the other things that we've been doing with interference, as we talked about, you say that the tinfoil, some people have said that's what the issue is. That's not predominantly what the issue has been. It's that they have the interference, which is why we use the ferrites. And so ferrites should minimize a lot of that effect because that's 95% of the time what the issue is. Now, I can't convey that it's 100% of the time. I'll never say that. The 5% that you do run into those issues and you really feel, hey, I don't want to use a tinfoil, that's when I suggest the 213, or there are other products that we do sell that don't have that, like the PTFE products don't have that. But that's typically when you're running a lot of power through there, and it's overkill for a lot of the things that you might be utilizing it for here. Yes, sir.
Okay, I realize about the skin effect, you know, on your center conductor, it's on the outside. Okay, thank you. The center conductor on the outside is where the signal predominantly goes, and your braid is on the inside, correct?
Correct.
Okay, so saying all that, let's say now you're taping the coax. Let's say LMR type, you know what I mean, your company,
Sure, yeah.
the 400,
Yep.
to a tower.
Okay.
Is there any kind of degradation because you're taping that thing to a tower? And the other thing is, let's say you have 2 or 3 cables in a bundle. One is on 2 meters, one might be on 6, another might be on HF. When these 3 are taped together, is there any interactions or between like capacitive type things or interference between the others? Thank you.
There is possibility that you could have some sort of interference, but what I will tell you is it's understanding specifically what cables you're putting together. Typically in this market, you're not going to really have that interference. If you're running it up and you're running 3 different cables, we do a lot of P-texting for like the government, for example, and they run a lot up the towers. So what we'll do is we'll run, we've run up to 10 different types of cables in a P-tex that covers that for their mindset, but that's a mindset of more of a safety thing. But putting them together and running them up there, you shouldn't run into any issues. If you do have interference, though, that's when we throw in saying utilize the ferrites. That usually 95% of the time is going to reduce out that interference. So it should not, running up a tower, have any issues. Yeah, no problem. What my father, Mark, who used to run the company, was saying was that you can also utilize standoffs, which may be if you feel uncomfortable running it straight up. Standoffs are just off that tower, just kind of running it up that connection so that you can run it off of plastic. If you feel uncomfortable or you feel like there potentially might be an issue, that is always a backup, but you don't absolutely need to do that. Okay.
Question I have is what, and I don't really know one from the other, but HRO always has me buying 25400 FPL. What is that?
Okay, sure. 25400 is that 400 or 8U size. That's the double shielded. I'll go back to that. So this is the 25400 flex. This, for the market, for HF 2 meter 440 up to 900 megahertz is a great product. This will suggest the stranded center conductor if you have a rotor. So if you're doing a lot of movement, you want to stay away from all those slightly lower loss, the solid, because the solid's going to break after a while. Because think about it. You in essence have a stick that you're going and you're constantly trying to bend back and forth. You're going to break that. Where you have the 400 Ultraflex, you have a much thinner number of strands that you run together. And so it gives you a very good stranded center conductor and allows you to utilize a very wide range of movement that you wouldn't be able to use with a solid center conductor. As well, like I said, 50 ohm, 10 gauge, so it's a stranded center conductor. So it's an RG8U size. So when they talked about like past years, 9913, 400 flex, those type of products are considered an RG8U size. But there's, as we say, there's different variations to it. But this is typically used 2 meter, 440, or even up from there. They are utilizing it a lot in some broadcasting, but they utilize it with BNCs. But it's a great product. This is, I guess you could say, it's the Cadillac of cables. It's a fantastic product, but it runs very well. Yes, sir.
Is there a way, if you have, say, a long conductor that's kind of cut in the middle patch without having to run over from that? Is there a connector device that will change? Right. I'm asking if I have, say, a 150-foot run out to my antenna, and someone cuts through it halfway through.
Okay.
Rather than run a whole new cable, is there a way to patch that cable? Is there a connector specified versus having to use 2 connectors and a coupler or whatever?
In essence, that is what it is. So you can either do a patch cable or you can do an adapter. But you're going to have to connect it. You can't just connect a center conductor to a center conductor without those.
They don't.
Okay.
Turn me off. They don't make a patch type connector that you can, put it together and it's similar size or.
That would be an adapter.
Oh, okay.
Yeah, the adapter is what's utilized for that.
All right. Thank you.
Yeah, no problem.
You had a question, Victor?
So on the solid center conductor, and using it in a rotor loop.
Okay.
I've got one of my cables has a solid center conductor, and the other 3 that it's bundled with on the rotor loop. Does that, having it bundled with the other 3 cables, does that give me a little better chance of that not breaking as opposed to it being by itself, or what?
I mean, it's going to depend on the angles, but if you're using a rotor and you're using a solid center conductor, the odds are that it will break down sooner than the stranded center conductor.
2 years and it's working, so.
And like I said, I say odds are.
Right,
So that's why
right.
we go typically with the stranded center conductor, but if it's not too tight of an angle, then yeah, you can get away with that. I mean, it's just gonna, odds are, if it's being bent as consistently as a stranded center conductor, it's gonna break down a little bit quicker than what you would get with that.
Gotcha. I tried to make it as small as possible, so it's not like a big loop going like this. It's a very tight loop, very slight curve.
Okay.
And it still makes it around 360 without any problem.
Well, I'd love to get a picture of it. So if you don't mind, if you grab a card, you can send it to Chuck. We always like to look and see what things are. So we're always trying to learn too. There's always new products that are coming out. You see we're adding different things. We're ham radio operators, KG5, MNH. My brother has been, my dad is, my wife is. I mean, we're all amateur radio operators. We sell to a lot of different markets, but the reason we sell this market is we love amateur radio. We like to come to the shows. We like to buy the equipment. We have fun with it. So we always want to see different things. And if there's things that you can do, now, we're not going to always suggest that, but if there's some certain angle that you've been able to get away with, then hey, fantastic. That's always something for us to see and understand. Yeah, no problem.
Yeah. The bigger the loop, the less fatigue.
Did you have a question, sir?
I have 3 questions related to burying the cables.
Sure.
So first, I heard that there are some filling materials that can be inside the cables that will kind of absorb the water and prevent it spreading down the cable.
Yeah, I mean, and that's in essence what we were talking about with the, which angle was it? I think it's, these are the cables. It was a Type 2A. We're going to talk about jacketing. Here we go. So the Type 2A jacket. Yeah, I mean, it's the elements and what they put into the cable that makes it a Type 2A jacket. Seen the process, but what's that?
Not the jacket,
Okay.
but something inside the cable, like the isolator, yeah, the gel type of a thing.
Yeah, I mean, if you need that, there is things out on the market, but typically our mindset is we try not to do that aftermarket. We build a product specific to the needs. So direct variable, for prime example, we build the jacket right so that you don't have that insertion of moisture into our cables.
The second question is, do you normally put a variable cable inside some sort of a watertight pipe or something like that?
You can do that,
Yep.
but you don't need to do that with the 2A.
Does it make sense? Will it make things better or worse? Because water gets inside that pipe, then the cable is constantly in the water, right?
It's constantly in the water anyway. So, like, for example, I live
Anyway.
in Houston. I think we're at pretty much at sea level. So us putting cable in the ground is like putting cable in the water, and it's constantly in there. You can put it in the piping, but that's the beauty of our product. You don't have to pay for the piping to do that. The only thing that a pipe is going to help is with animals. It's going to prevent them from getting in there because it's hard to chew through PVC pipe. It's easier to chew through this, but because there is a lot of oil in cable, typically animals shy away from biting into it. If you notice, I mean, we sell this cable all the time. I would have thought we would have been selling a lot more of it with the steel braid, but nobody ever needs it because they're like, it's not getting chewed into. So once in a blue moon, I'll hear, squirrel got into it and bit into it, and I got to buy it, but 99.9% of the time, it's not happening. So you don't really need it unless you feel like I got a squirrel issue or a mouse issue or something. You know, you're by an open field. That typically can create some of those issues, but it would be more associated with an animal versus the environment.
And I'm just planning one. Yes. Yes.
You want to go with a bigger, do you mind, Ben?
No, go ahead.
Okay. You want to go with a bigger pipe, so when you add additional cables going forward, you already have it. But the best way to do it is when you're running pipe is that you've got drain holes in it along the way and let it sit in pea gravel so that it dissipates the water.
But I will clarify, though, that you do, with the direct variable jacket, you do not need
Right.
to run it in pipe. If you're going to run pipe, that's a good suggestion. Is always give it air holes. But if you're just you don't need to run pipe to use.
But otherwise, you can go directly. My cables are all on the ground.
Yeah.
Okay. And last question, maybe strange a little bit, but I read about underground antennas built from, cables. Which cable is better for that, or is the best for that?
Actually, in the cable side, you can use any of them. Like I said, all of ours have that Type 2A jacket on it, which means they're all direct variable, even including the 213. Now, the PTFE is a totally different jacket. That's not a variable. It's predominantly for inside use, not for outside use. But all our cables from the 195 up to the 600 are going to have that Type 2A jacket.
Back to the ferrites.
Sure.
Placement of the ferrites. Closest to the transceiver? It's
typically, so if you look outside, if you go to, they're just outside in HRO, it's typically, I don't know the specific math, that's going to be Chuck on the physics side, but you're going to have probably about 6 inches off of the connector is what you typically would do. We typically do it. And the reason we do it is because you can do the snap-ons, but if they're in line, it's going to allow for a better connection as well. So that's why we use inline ferrites, is because it allows connector. We can lock it in a specific way, which is what we do. I'm not going to give away the process, unfortunately, but no, we lock it in so that it doesn't get there. It's covered, and you never run into an issue with it. What we're doing is we're preventing long-term issues for you so that you don't get moisture into it, so that it's not moving around, so that when you're utilizing our cable, you're utilizing it for years to come with no issues. But it's got to be in line. It's typically around 6 inches, but it's also dependent on the length of the cable. For more details, Chuck, if you want to grab a card out there, you can talk to Chuck about the specifics. He's a physics expert. Like I said, you want statistics, I can run the numbers for you, but physics, he's much better about it than I am. Oh, okay. The transceiver is typically where most people put it. So I misunderstood your question. The transceiver is where most people put it, but you can put it to the antenna too. It prevents across the board. It also depends on how much you want to minimize the effect and how much effect you're having, because there's some people that have extreme effects, but it's more associated with the cable than anything because they're using a poor cable. Because if it doesn't have a strong enough braid coverage, it does have a significant effect. Yeah.
Do we have one last question before we?
All right.
All right. Well, hold on.
Do you have some of this already on YouTube videos? Because we missed a good chunk of the presentation, so it'd be good to reference everything we missed.
This will be here on this presentation as well. To give you some perspective, I know Chuck, as well as to a lesser extent Shannon, just did a video. I'm not sure specifically where the video is from, but I know it's on our site, and it's about a 20-minute video. It gives you perspective about the machinery and about the process and what we do, because we do a lot of different cables, and that machinery, when you start to break down, I mean, I'm sure if you've tried to strip cable before, it's awful difficult. And doing it by hand, and even one of those hand things that you have, they never work nearly as well. And you want a precise connection, because when you put it up, you don't want to go back up there 2 years later. You want to go up there 20 years later. So you want to be able to set up your antenna and be able to utilize it. That's the beauty of it, is making sure that it's all connected correctly. But if you have any other questions or you want to see the video, go to the website, our website. But as well, I have cards. You can just reach out to Chuck. Chuck is the expert, and he can talk to you about all the details. I know about 96% of it, but the other 4% I always defer to Chuck. So, But I appreciate everybody's time. And like I said, if you have any questions, don't hesitate to reach out to us. I know the stores reach out to us regularly on questions. We're always here to help. Okay? Thank you very much. Thank you.
All right, thank you, everyone. And Ben, thank you. And yes, definitely stop by the booth here and ask more pointed questions because you'll probably get a better chance to get some of those answers there. So
And don't be shy because I never am.
yeah, don't be shy. So all right, coming up next is Gary Sutcliffe, W9XT. He's going to be talking about low band or low frequency antennas for reception. So please come back for that coming up here at 11. So thanks.